Okay, so now we can start. Good afternoon. Smart cities. We are already on the fourth lecture today. And it's amazing how many requests we get here at the chair and me personally to shed light on this particular topic. I don't know what is happening, but seems to be very, very timely, this topic. And today we want to concentrate on the criteria so that we get a better grounding on how to define smart cities. It will be done by Estefania Tapias here and myself. And the topic will be on urban measurements and the criteria, because we think that you have to measure, that you get data, that you can make information, that you can produce knowledge out of this, and that will be the main topic of the lecture. The story so far, at the beginning, we stated that cities are complex systems. Then we had this overview by Mark van der Net with this inspiring lecture. Then last week, we introduced stocks and flows, and you gave quite some ideas, additional ideas about stocks and flows. And today it will be metrics of smart cities as basic instruments of urban research. We positioned here between the big data, stocks and flows last time, and citizen design science next time. So before we move on to this topic, we have to speak about urban measurements, measurement and simulation, and how the criteria for these measurements and for these data are to define smart cities. It is quite amazing to see the results of your first exercise, because many of them came in now. Those of you who haven't done it yet, there are more people here than we have exercises. I can see that. Please do that as soon as possible. And to compare those to the exercises that your colleagues out there in the world did. I don't know how many of you had a look at what they did, but it is quite amazing to see the similarities and the differences, because many of these people do not have architectural backgrounds or design backgrounds, and therefore it's interesting to compare. Please, here, places in the front. So what we will do also in the lecture, the first lecture after your break, the seminar week next week, so today in 2 weeks, we will look at some of the exercises that you produced, the others produced, and draw some conclusions from that. Okay, so content for today. Urban research. First you have to see what urban research is or why this is important. Then the criteria for smart cities, and from the criteria to the metrics that will produce data. And then measurements, how you actually get these metrics, how you actually get those data. And in this context, Estefania Tapias will report how she has done that actually herself and what she learned from it. This is very new. This was happening last week, and maybe that's a good introduction to the topic of today. You see from the United Nations Environment Program, this reporting that it was signed a treaty to reduce the emissions of HFCs, as they are called, in the future, and this being a major contribution to the temperature decrease, hopefully, of the globe in the next 50, 60 years. What does that have to do with our topic today? You know that until recently, many people were debating or saying it's not true that global temperature change has to do anything with human-made actions. Other scientists said, no, this is so. And by now, it's more than 95% of the scientists believe or are sure that humans are contributing to the rise of temperature worldwide. And not only humans, but also, of course, things that humans make, like machines, like these hydrofluorocarbons that contributed to the global warming. But in order to do that, in order to believe this, you need some kind of data. You need some kind of model. You need some kind of criteria so that you can make such far-reaching, long-lasting decisions based on the get-together of politicians and decision makers from all over the world, basically. So this I take as an example, and keep that in mind as a positive example. Keep that in mind when we move now to the content, because this is part of our habitat research, and habitat is the entire human habitat or habitat of all living beings on this planet. And habitat research, which urban research is a part of, is of course based or should be based on science. And if it is based on science, then measurement and simulation are necessary. And not only that, it is also influenced by people, of course, and in that respect, the behavior of people has a big impact on the measurements, on the simulations, and on the results. In our context of the city, we consider three types of research. The one is the building research, the other urban research, and the territorial research. And if you remember last lecture on stocks and flows, we also had these three scales: the building, the city or the neighborhood, and the territory. And if you look at the building research, it means to understand the building and their internal stocks and flows and their interaction with people, with cities, with stocks and flows of other kinds. But in building, the impact of people is very, very strong and very, very visible. You can just imagine that. Take this room. If I ask you to open this door, this window, and you open it, and everybody will feel immediately now that it gets cold, and in the summer maybe it gets hot. So the impact is direct. We can measure the temperature drop in this room when you open this window, and we can also see then the change in your behavior. Maybe you will turn on your jackets or say you start shouting and close the window or something like that. So it is very, very close relation between measurement and the behavior of people. Simulation would be the activity of having a model, a concept, how this relation is between opening the window, dropping the temperature. You could simulate that based on the size of the opening door and the temperature difference between outside and inside. You could simulate and predict how much the temperature drop would be in this space and in your space path over there. Where will it be biggest? What do you think? Right here, yeah. So you are safest back there. You will not suffer. But it's very, very clear what happens. And in one space, you can simulate these things. You can predict this to a high degree of precision. But the impact of behavior of people is also very clear. If you jump up then and close the window, it stops. In a city, when we look at the urban research, and this is our context here, understanding the cities and their interaction with people is of course important, but we have many more people and their individual actions might not be as strongly visible as it is in a building. Except, of course, if you have terrible accidents or terrible terroristic acts, and very few people can have a big impact on the functioning of the whole city. And then if we move to the territory, it is understanding regions, countries, and their interaction with stocks and flows, and it is also a picture of complex systems, just as the cities, that you can make explanations, you can understand it, but predictions are getting more and more difficult. So in this context, I want you just to keep that in mind. We go back into history a little bit, a few years, in the 1960s, 1970s. Who remembers the name of this book, or this, yeah, it was a book. This morning, yeah, good. So you watched the MOOC. That's good. Anyway, this is from Christopher Alexander, and he was a thinker in 1960s and 70s. He still is. And he was a mathematician, but he was very, very interested in buildings and cities. And he's one of the first one who really tried to bridge this gap between mathematics and architecture and urban design. And his very early writings, therefore these early writings are quite interesting because they are still rather raw. Maybe not so sophisticated, but he really tried to make connections between what he observes and what he knows. And he writes in this article, I want to call those cities which have arisen more or less spontaneously over many, many years, natural cities. And I shall call those cities and parts of cities which have been deliberately created by designers and planners artificial cities. Siena, Liverpool, Kyoto, Manhattan are examples of natural cities. Of course, if he thinks Manhattan is a natural city, then if you go back to the time when Manhattan was planned, at this time probably seemed like an artificial city, and even according to his own criteria. Levittown, Chandigarh, the British new towns are examples of artificial cities. And then he moves on and says, it is more and more widely recognized today that there is some essential ingredient missing from artificial cities. When compared with ancient cities that have acquired the patina of life, our modern attempts to create cities artificially are, from a human point of view, entirely unsuccessful. And then he looks at how to represent a city. The first shot was at a tree, but he says both the tree and the semilattice are ways of thinking about how a large collection of many small systems goes to make up a large and complex system. More generally, they are both names for structures of sets, which is his mathematical expression of that. And if you then look at this definition here, or urban research, understanding cities and their interaction with people, territories, stocks and flows as a complex system, that comes pretty close to his definition that he had at this time. Then he goes further and says, the city is not a tree. This is the traditional society, which was a closed group of friends in a village or in a very small part of town. You know everybody, everybody knows you, but it's a close group of people. And in reality, in modern cities, people know each other through different connections, what he calls these representations as lattices, and therefore there is no closed group anymore. For you today, this is of course totally clear, because groups like search engines, Google, Facebook, all of those take, of course, this view and implemented this view in their program. So this is actually how we interact today, whereas here, this might be more like the traditional way of a military structure. But a city doesn't work like this. A city works more like this. And therefore, this Christopher Alexander in his early writings is still quite important. And out of this, you can see this long, long, long way, what I showed last time, comes this simulation of transportation, where all these different people, artificially made people, cars, streets, infrastructure, and time are interacting, and then you get this type of simulations. So it's a long way from Christopher Alexander's view on the city to these simulations. But it's a logical step following one of the other. The one thing that is always not missing, but underrepresented, I would say, is the impact of the human being, of the person, the behavior of the person in the city. And you can see that in yourself. We might know many, many facts, but we might have a completely different reaction to these facts. Okay, now let's go from this overview to some of the criteria of smart cities. Questions so far? not yet. Good. So, criteria for smart cities. Another picture from the newspaper not so long ago. Path, do you know somebody in this picture? Uh-huh. Okay. So Path is obviously from India, and he knows, of course, the story about the smart cities in India. And the approach of the smart cities that we see here is that the objective of the government of India is to promote cities that provide core infrastructure and give a decent quality of life to its citizens, a clean and sustainable environment, and application of smart solutions. The focus of this mission is on sustainable and inclusive development, and the idea is to look at compact areas, create a replicable model which will act like a lighthouse to other aspiring cities. So here we have a country, a government, which is striving actively to create smart cities. And this is such a good example because they put down their criteria from the very beginning. And here are the criteria. The core infrastructure elements in a smart city would include adequate water supply, assured electricity supply, sanitation, including solid waste management, efficient urban mobility and public transport, affordable housing, especially for the poor, robust IT connectivity and digitalization, good governance, especially e-governance and citizen participation, sustainable environment, safety and security of citizens, particularly women, children, and the elderly, health and education. So these are the criteria for the Indian smart city. And when you read that, and some of you come from places where most of these things are already present, you ask yourself, why is this smart? Maybe you do ask yourself, why is this smart? Let's have a look at the criteria of a smart city from the European perspective. And here they are. European Innovation Partnership on Smart Cities and Communities. This is the fantastic thing about the European research, because all these research results, they are listed, they are openly accessible, and you can go into each one of these criteria very, very deeply. And you see already, it's the same name, smart city, but the criteria are different. First, sustainable urban mobility, and so on. I don't want to read them all, but you can see there is already a difference. And I tried to put them next to each other. Or first, even if you go into one of those, for example, this point 8, baseline performance indicators and metrics, our topic today, performance indicators and metrics, measurable data, they then break it down into even more detailed steps. So first, scoping of indicators, what are there? Then the gap analysis of existing indicators, develop the missing indicators, agreement on the indicators, define a baseline and pilot key performance indicators, create the ecosystem required to enable the use of the KPIs, and so on. And then analysis of the status quo. How do you do that? So you have a really detailed analysis how to measure the city and how to fulfill those criteria. Now we put the two views together, and now you can compare yourself how they are related or not. So on the left you see the Ministry of Urban Development in India, and on the right you see the European Innovation Partnership in Smart Cities. So think for yourself, and let's stop at this point a little bit and discuss this. Is it possible at all to define one smart city in the world? Or do you see any of the criteria that are related? Maybe we can start with this. That's simpler. Yeah?
It's probably a lattice as well, not a tree.
That is, both of them are lattices, that's right.
Oh,
yeah.
well,
In here, yes. 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 And as your question was last time, regarding the quality that is also sitting in each one of those, but quality at a different time might mean something different as well. And as you see of some of these criteria, they are of course related to others that cannot be fulfilled without the second one. So where are they related? What do you think? The machine is quite loud today, yeah? The screen is having its own life today. Well, let's have a look at what is missing. So in this one here, you don't find anything about water supply, and this is the number one here. So it seems to be that they take it for granted, you could put it this way, although it might change here as well, and then suddenly it might appear. But here the citizen focus, for example, and I'm on the 4th place, here on 7th place, good governance, especially e-governance and citizen participation. I think this is very important that that shows up in both definitions of smart cities. Then the whole question of data, of open data, of baseline performance indicators and metrics. We have 2 points, and 3 points actually, 8, 9, and 10, and standards focusing on data and how to secure that you can measure the criteria and can define the smartness of a city with that and can improve the smartness of a city. Here, that is more coming in, maybe built in some of it. Here, robust IT connectivity and digitalization. We have it here, but with a different impetus. Anyway, I think you can see for yourself there are different criteria, they have different meaning, and they definitely have different priorities in these 2 definitions, and always keep that in mind when you talk about smart cities. Now let's come to some metrics. Maybe that makes it a bit more understandable. One of the film teams which was here to film our work on smart data and smart cities and responsive cities, they said we explain things, but they're hard to understand sometimes and too abstract. Let's try to be a bit less abstract. I hope it helps. This book that I showed in the first lecture, The Responsive City, there's a quote in there, which is, I don't think from him, but Michael Bloomberg, the former mayor of New York City, said he has a rule of thumb. If you can't measure it, you cannot manage it. And if you can't measure it, you cannot improve it. This is the other saying. Here we have a sad example of something missing. A Spanish bus last year went into a tunnel which was not tall enough, and it took off the entire roof of the bus. 30 people were injured, 4 of them heavily, and one traveler reports that he was sleeping and suddenly heard this loud noise, smoke and broken glass, and blood, and he was injured only lightly. There are 59 passengers on board, and it went from Bilbao to Amsterdam. And obviously, that is their conclusion. The chauffeur of the bus had driven this bus with his GPS system and did not look at the warning signs indicating the height of the tunnel. So what does that mean? Something was not smart in this accident, of course. Fortunately, nobody was killed, but it was a terrible accident. And we could, now if we look at our course here in our lecture last week, it could be seen as an interaction between an urban stock which is the tunnel ceiling, which is really a stock for the time being, and an urban flow, which is the transportation in this case. And what is missing is the exchange between those, or the correct exchange between those. So there is a model, of course, for the city, for the whole transportation system. The model is the street, the bridges. The bridges are specified in their height, or the tunnel is specified in its height. So the measuring is there, because that height is given. Then there should be the checking of the flow. If that flow fits under the stock, the checking has to be done. It has to be done understanding. They have to know these are centimeters or meters and not changing values. Therefore, the standard setting for these measurements is important. There has to be a warning. Obviously, the bus was not smart by itself, because if it had seen, or the system had seen the sign of the tunnel height, it should have stopped the bus automatically, and then there should have been action. The action being hit the brakes and don't drive into the tunnel. But of this whole sequence, from the model to the action, or you could say from the model to the simulation result, many points were missing. Let's look at another example where it did work. Stefania, now we have to change this one. So here, just a second. Here we have a situation in the Alps, here in Switzerland, not so long ago. And this part of the whole mountain, they had somehow measured or seen or measured or felt or whatever, that something was not right, was moving. So they were looking at this. They had a model. If something is moving in a mountain, it's coming down sooner or later. They were observing it. They were simulating it when it would happen. They measured the movement of the individual piece, and they took the appropriate action, meaning stay away, film, observe the whole thing. Let's see if it works. So that was just a year ago. So look at this. It's like 20,000 tons of stone crushing down. So in a way, it's a very brutal but also very beautiful demonstration of the stocks and flows model, something that is really sitting there like a rock. You think will never, ever change. Suddenly breaks loose, turns into a flow. At the bottom, it's just dust and stones. But the point is here, they really were watching it. They were predicting it. They had the model that it would come. They did a simulation. They put warnings up. They took actions to film it, because from that filming, they can learn for the next such event, and so on. So I think this is a very good example of interaction between stocks and flows, measurements, predictions, and criteria, in this case, of danger. And the other one that I also showed you briefly, where the warnings were not taken, where a very sophisticated culture existed 2,000 years ago, in this Pompeii example from last time, and a very highly developed art was existing. So people didn't lack sophistication, understanding, simulation, knowledge. It was all there. But the warning signs to the local residents, the mountain was just a mountain. This Vesuvius mountain was just a mountain. And it was very fertile and would have been covered with vineyards and small villages. The volcano was lying dormant and had not erupted for hundreds of years. But the first indication of the disaster ahead was in 62 before Christ. A destructive earthquake occurred which caused streams and wells to dry up. Streams and wells, so the water was stopped from coming down. People knew if that happens, something is clogged inside. It damaged many buildings in Pompeii. And even a sculpture that was done at this time showed that one of the temples, the statues were leaning. That means that they were shifted. It was even kept as in a drawing, in a relief. It was not something that was seen and forgotten. It was there. It was documented. And even before the actual earthquake happened, again, there were warning signs, but people did not act. So there was the model, there was the measuring. People knew that from before. They did some checking. They saw, okay. But the understanding, warning, action, all of this did not really happen. And the result was this terrible disasters where more than probably 20,000 people just died, suffocated, and were covered with dust that was only rediscovered and removed a few years ago. So, terrible. Let's go to something more constructive. And we start with Estefania Tapias. I think we can jump over the first two ones. This is from the...
Yeah, I think I took them.
You took them out?
Yes.
Okay, good. Yeah, go ahead. Okay,
Yes,
you
I
go
took
ahead.
them out. Okay, so now I'm going to show you more about the data collection and how we've been doing it nowadays, and of course to get into the knowledge. But we always start from the idea of what is data, what's information, and what's knowledge. So more or less what was shown before, but in more simple words. And in this case, for us, the starting point of data collection is to understand what's data, what kind of data we have to collect, and for what reason, and how data and information can derive to knowledge, to understand and to make all the next processes. So as seen maybe in this image, the data is the smallest entity of information. So it's just values given to objects. And in this case, this is just data from a weather station, but in numbers. So it's just the dates, temperature numbers, solar radiation numbers, wind numbers, but it's all numbers. If we don't have a code, or we don't have like a word that tells us what it is, it's just numbers, right? Then we have the information, so the connections or relations that we have from data can derive to information. And this is just an example of a console of a weather station. And before, we had just the numbers that could be anything. But then here, we have the relations of the numbers. So we can see that these two are humidity, then these are the temperature, this is the number to the rainfall, and so on. And then we also have the hour, the time. So then here we can understand what the numbers say, or what they relate to. And then, of course, as mentioned before, we collect data also to understand what's going on and what's happening in the current situation. So to be able to understand what's going on and its performance, like its present performance. So there have been many projects that try to collect this data in cities just to understand what is going on, what's happening. Different examples of travel patterns, for example, in Singapore. And then we can, from this data that it's collected in the city, we can derive to some conclusions. And then today I'm going to show you maybe something, sorry, this is just bothering me. I think the dog was playing with this before. There was a dog running here. And I'm just going to show you a simple and very small example of how I used a data collection system based on two different methods to understand what's going on in a city. So here I just collected data from weather data and also from the citizens. I'm going to show it to you afterwards to understand what's the OTC, which is the outdoor thermal comfort. So what is the comfort of people in cities in the outdoor environment? So I divided it into two parts. So the local scale and the city scale. So we can collect data in a very specific location, just in a campus, or even just in a building, or even just in a balcony. We can collect data. And then we can also have a city scale collection data, which was, for example, the picture I show you of massive data of travel patterns that you can collect in a city. There's also different type of data that you can collect. Here I divided it into quantitative and qualitative, but it's mainly, it could be based on numerical data. So for example, the data that I showed you at the beginning of the data of the weather data, or you can also collect data based on empirical models, like for example, asking questions to people. So doing survey campaigns and getting the people involved in what type of information you want to gather. So the first part of the project was the data collection in a local scale. And then for this, we created a project and a measurement system that we installed some small weather stations or portable weather stations. And then we could connect it to a computer and then later on to our online server. And we could then, this is the weather stations. We installed different weather stations, and then with the server you can monitor the different data that was collected in each of the weather stations. These weather stations were installed for 1 year, so it was very important for us to be able to monitor the weather stations from an online server. And you can find different online servers that can produce also different statistics on the data. So as you can see here, and then the main data that was collected. Yeah, this is more images of the statistics. And then that's just a very simple way of just collecting data. Do you have a question? No. Okay. So that was the part of the simple data collection. Then we also did a data collection on a survey, based on a survey campaign, because we also wanted to understand how the people were feeling. So with the weather stations and the data collected with the weather stations, we used that data and we input it in a model to calculate the thermal comfort of people, but based on a numerical model. But then we also wanted to know, okay, what's really what the people are feeling, and then we can compare it and we can validate the both of the methods. And then that's how we went into the second part. And then we used a simple survey, and we did a survey campaign asking people how are they feeling, what is the degree of satisfaction, what would you prefer to do, would you prefer to have more to be warmer, colder, and so on, different questions. And we did this survey campaign for 2 weeks, so we could have different ranges of data. And that was the first part. Then we thought, okay, we want to take it to a city scale, because we not only want to understand what's happening in a local scale, but we also want to see in the city how it's happening. Then so after doing some validation from the local scale, we took the survey campaign and then we translated it into a smartphone application. And we did a marathon for two months in the same city, where we promoted the smartphone application, and then we wanted to do a crowdsourcing on how people were feeling. So we actually took the same type of questions, but we simplified them, of course, because in a smartphone, for people, it's easier just to answer 3-4 questions and not like a whole page. And then we spread it around, and then for 2 months, people were answering different parts of the city, how they were feeling. We also had an online platform, and we can also monitor what people were responding in different times of the 2 months and different types of the day. And then we also show them, or we also ask them to go to the website, and they could also see what other people were feeling and if they were answering similar to each other, and so on. So this was just an example we did, how we extended, or our approach of extending the local research that we were doing into a bigger scale, into a city scale. And this is not the only project around the world that it's trying to gather information and collect data from citizens. There are different other projects. Similar one, it's called the Smart Citizen. This is just another example. And what this does is it's a small device. It's just this device. And what it does is that it collects also weather data around, it collects weather data, and then they distribute it around the world. And then around the world, there are a lot of these little devices installed. And then they also have a big platform. And then you can see a world map where, and you can see all the data that it's collected. So why am I showing this to you? Because I don't know, for those who have seen already last week's MOOC, we're also trying to do the same with the MOOC. So we have, we also did it beforehand, so we also tried to collect information from participants in the MOOC. And then this time, Lucas Treyer, which is in that corner, one of our colleagues, he developed this app where we can also collect data, numerical data, and also empirical data from the participants. So who has done it already? Who has? Oh, quite a few. So with this, the idea of this tool, as I mentioned before, is to show and to share with the participants what could be a data collection project and what kind of data you can collect. And here we only put some examples. I mean, at the end, you can collect any type of data, or anything that you can imagine, or anything that you want to understand. But in here, we only put some examples. So for example, the first one is the measured temperature. So the idea was either to use a smart device like a smartphone, or to use a simple thermometer, just to add where you are in the world. So this is a world map. And then introduce what the temperature was, just by reading any type of device. We also wanted to collect the perception of what you are feeling. So one thing is to collect the data from a device, but the other one is to say, how are you feeling? Also, we had a range from 1 to 10, 1 being very cold and 10 being very warm. And then you choose from this number, how did you feel? And so on. We also had for the noise, and we also had a general satisfaction of the place from 1 to 10. So I just want to ask for the ones that already did the exercise. Do you have any comments about it? Any questions? Any satisfactions?
Was it difficult?
Yes.
There wasn't a way to tell at what time we did the measurement, right?
Timestamp. Time,
Oh.
what time?
So it's recorded by the app. You don't have to put the time.
Uh-huh.
Okay, so very simple, very straightforward, right? No confusions? Perfect. So for the course, just to have a summary of the different exercises. So at the beginning, we already did the exercise 1, part 1. Also for the ones that haven't handed in, please do it. But now we are in exercise 2, so 17th of October, 10, sorry. The data collection exercise, to handing the data collection exercise, is on the 31st. So here,
October.
that's 10, of course. And again, we ask you to, this is the second exercise, we ask you to go into the edX platform, read on the exercise, so this is the explanation of the exercise, click on the link that you will see already, the browser that I showed you before, and then which is this one, and then for our course, please again send a screenshot, And in this case, just an explanation of the area you collected the data. So if it was here in Science City, just to say it's Science City, it's one of the campus of ETH during this time and so on. So just to explain, to make a short description of the location. And send it to me and to Professor Schmidt by the 31st of October. Okay. Oh,
Okay.
sorry, just one last thing. When you send the exercise, please send it in the same document. So take a Word document and put the screenshot there and the description. So it's easier for us to save the exercise. Okay.
All right, so that might seem very simple what you saw now, but it's really to put to the point what data means and what your own perception means, your own behavior and data, that you see a relation between those two. Do they coincide? Do they make a difference or not? This is very, very important because many people believe that smart cities, you just have to throw these sensors all over the place and then you know the city is smart or how it behaves. It's not so. You need to have this human component. That's why we ask you, how do you feel? Is it cold? Is it not? What is your general feeling about this place? And then we can see in class, we can compare the same temperature, the same place is felt by different people in such a different way. Why? And then you can start to ask yourself. This is the basic idea. Also, what I mentioned before, this difference between the data, the numbers, and the human behavior is very important in every smart city and will become even more important in the responsive city. And that's why Estefania Tapias also, she took the data, she took the measurements from the roofs all at the same time, at the same place, so they were totally compatible, controllable, not recreatable, but you trusting the thermometers and the wind speed meters, you could say they were really happening at this time in this place. But the way people felt might have been completely different. So this outdoor thermal comfort right next to those places might have been completely different from what the meters told you. And this is something we really want to drive home, that you remember that in everything you see and hear about data, about information, and especially about smart cities. So, the summary. Urban research requires measurements. Without measurements, it would be not really research. Resulting in data. If data are combined in a meaningful way, they turn into information. Information is something you can do something with, you can understand. And if information is combined, it turns into knowledge. And after a while, if you're 80 years old, like the architects, when they are very old, they start becoming very smart and very experienced. And this is really knowledge. And this knowledge is extremely valuable. Information and knowledge combined with observation and compliance are needed to improve a city. So it's the knowledge made out of data and information combined with observation. This is coming from the people. This is the important part, to combine those. If you want to understand urban systems, the measurements are important on all scales: buildings, neighborhoods, districts, cities, regions, and territories, because they're all interrelated. And we have to see, if you measure them, if we can make these relations. Measurements are necessary, but not sufficient activity for quantitative and qualitative urban improvements. So we can measure the wind speed in this place here, in this street. We can measure it. We can also simulate it. We know why in winter it's getting very cold and the wind is going through this way. We can observe your feelings. It's cold, it's too cold, it's too much wind blowing. We can improve that situation if we want. If we want to invest the money to do that, we can improve that so that you have less wind. So this is one simple example how you can use qualitative and quantitative measurements to urban improvements. Ignoring information and knowledge or not having access to it can be really deadly. We have seen it in the example of transportation. We have seen it in the example of Pompeii. But we also see very good examples. If you do not ignore it, if you acknowledge it, if you see it and you make sense of it, you can prevent all kinds of disasters, and most important of all, you can improve the performance and the livability of your city. So with that, let you go, and I wish you a wonderful seminar week. Think of these things. Everything you see, think about it. What is a stock? What is a flow? What is moving? What is resting? How is it related to something else? And think about your measurements. And next time when you come back, we look at the examples from your first exercise. So have a good week and see you next time. Thank you.